So far, we have seen division problems where all the objects can be divided evenly and there is nothing left. So for example, with our problem with 12 apples can be divided into 3 groups of 4 without any leftovers. All 12 of our apples are used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All 12 of our apples are put into 3 groups of 4 apples each. Also, all 12 of our apples are used when we divide by 4, and we have 4 groups of 3 apples each. So we still have our 12 apples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we divide 12 either by 3 or by 4, we end up using all 12 apples. Each of them is in a group that's the same amount per group, and all 12 apples are used. Once the division is done, all of the 12 apples are in a group. There is no apple that does not belong to a group. But what if instead we had 13 apples? So if instead of 12 in my total, I have 13 apples. So I now have one more apple to work with. So let's try to decide where that apple would go. If I try to put the apple in any of these groups, there's no way for me to distribute all 13 apples evenly into, say for example, 4 groups. If I try to put one more apple here, if I try to put our 13th apple here in this group, then my groups aren't the same size. These 3 have 3 apples in them, and this one would have 4 apples in it. We can't have that with division. All our groups have to be evenly numbered. Every group has to have the same number of objects in it. The same thing would happen if I tried to put the 13th apple in this group. I can't put it in this group, and I can't put it in this group. There's also no way to make groups of 4 apples using all 13 apples. So in this case, I have my 12 apples in 3 groups of 4 each. And so if I'm trying to find a way in this situation to add a 13th apple, I can't, because if I put a 13th apple here, this group will have 5 apples in it, and it can only have 4. The same would go here or here. So both times we end up with an extra apple, and there is simply no whole number that can correctly solve the equation 13 divided by 4 equals what? Or 13 divided by 3 equals what number? We don't have a whole number here that we can put for the answer of 13 divided by 4 or 13 divided by 3. So what do we do? How do we solve a problem such as this? To solve a problem like this, we use something called a remainder. So this extra apple that we had, our 13th apple, I'm going to draw a little extra right over here, okay? And on this one, I'll draw this little extra right here. Now this extra apple, this 13th apple in our problem that we've been looking at, this apple is actually called a remainder. This one here too is called a remainder. So instead of trying to cram that apple into one of the groups that's already full, we can't do that. Instead of trying to cram it in, we simply set it aside and acknowledge that it's just an extra. It's another way of saying it is that this is the remainder apple after dividing up all the apples into evenly sized groups. So in our problem here, for example, of 13 divided by 4 equals what number? And I'll erase this just to give us a little bit more space. 13 divided by 4 equals what number? We would write it like this. 13 divided by 4, so we've got our 4 groups, and we've got 3 apples per group. So our answer is 3, and then we just put this little r here after that and put a 1. So I would read this as 13 divided by 4 equals 3 remainder 1. And to write it in another way that we write division and that we're going to learn to use for long division, it would look like this. 13 divided by 4 equals, we put our quotient here on top, equals 3 remainder 1. And I would read this the same way as I read the one above it. So, putting boxes around here to help us see, I would read this 13 divided by 4 equals 3 remainder 1. And this method and these remainders become very useful when we start doing more of our long division.